Hey guys, hope we all had a nice spring break. Today we're going to talk about polygons. So polygons we've actually been working with a little bit. We've been working with triangles. That is a type of polygon. A polygon we define as a simple closed figure formed by three or more line segments. And the line segments all intersect. We call those the endpoints. We call those endpoints the vertices. So, example, like I said, we've been working with triangles. And the vertices of the triangle are where those line segments intersect. So this is an example of a polygon. Another polygon would be like a quadrilateral, we call it, where we have 4 sides instead of 3 sides. So we have like a triangle here. That's when we have 3 sides. A quadrilateral is when we have 4 sides. And there's also special, specific types. Like we have equilateral triangles, scalene triangles, isosceles triangles. With quadrilaterals, we have subgroups. Like there's rectangles and squares and trapezoids, kites, rhombuses, parallelograms. Those are all types of quadrilaterals. But everything that has 4 sides falls under the category of quadrilateral. We also could see something like this, where we have 5 sides. We call that a pentagon, and there's special names for some other ones as well. Generally we go, let's see, 6 sides, we call that a hexagon. 7 sides have a couple of names, we call it a heptagon, also sometimes called a septagon. 8 sides, we call an octagon. 9 sides is a nonagon, and we'll stop at 10. 10 sides is a decagon. As there become more and more sides, we kind of stop having special names, and we just stick to using just a number. Like if we had 17 sides, we would just call it a 17gon to signify that there's 17 sides. Now some special things with polygons. Well, let's say we're working with, let's do a pentagon. Say we have 5 sides, 1, 2, 3, 4, 5. So the amount of sides that you have, in this case we have 5, that's also going to be the amount of vertices you have. 5 sides, you're going to have 5 vertices. And that also is going to be the amount of interior angles that you have, angles inside the polygon. So that would be 5 angles here, because this is a, this is a pentagon. So that means we have 5 of everything. 5 sides, 5 vertices, and 5 interior angles. And we're going to talk about how we can find the measurements, or the sum, of all these angles inside. Now, we'll talk about this briefly. It'll come up more in the future. But just like when we named triangles, we're going to write the vertices in order. Like this we would call just pentagon. There's no special symbol for it. So pentagon, A, B, C, D, E. And when you're listing or naming a polygon, you just go around the outside. You list the vertices in order. So A, B, C, D, E, you want to list them in that order, going around like you're making one lap around the polygon. And again, to be a polygon, it needs to be what we call closed. What that means is, let's say we have a shape like this. Well, clearly this isn't closed because there's an opening here. So it needs to be connected at the end, and something that looks like this would also not be a polygon. We're not going to have that intersection. There should be no intersection. We should have a space in the middle. So those would be non-polygon figures. We're going to stick with polygons. So let's look at some special relationships. We're going to move on to the second slide here. So the second slide, we have a table, and the table, we have the sum of the interior angles, and we also have the number of sides. And like we just said, the number of sides, that's also going to be the number of vertices and the number of angles as well. Alright, so let's start with the first one that we have here. With a triangle, well, we knew a triangle has 3 sides, 3 angles, 3 vertices, and we talked about how its angles add up to 180. Our next shape looks like this. This would be an example of a quadrilateral. There's 4 sides. And if we don't know the angles in a quadrilateral, these 4 angles, they'll have a sum of 360. And the next one we'll look at and see if we notice a pattern. A pentagon. You have 5 sides, 5 angles, 5 vertices. And if we don't know this one's less known. These angles, these 5, when you add them up, they should be 540. Now if you look, every time you add an extra side to the polygon, you add 180 to the angle sum, the sum of all those interior angles. There's actually a special formula to calculate what the angles are going to add up to based upon how many sides you have. And that formula looks like this. S stands for, like the sum of the angles, so sum of angles. That's going to be equal to, well, that 180 is going to be really important. It's equal to 180 times the number of sides you have minus 2. N is number of sides. So the number of sides is n here. And how this equation works is you would take the number of sides you had. So let's say we didn't know triangles added up to 180. You would take the number of sides, 3, do 3 minus 2, which is 1 times 180. So a triangle adds up to 1 times 180, 180. Or if you had a quadrilateral, let's say we didn't know quadrilaterals were 360. Then you would put a 4 in here, and you would do 4 minus 2 times 180, which is 2 times 180. You get to 360. So as long as you know the number of sides or the number of angles in a polygon, you can use this formula right here to calculate what the angle, the interior angles are going to add up to be. And this can be really useful. So let's do a couple of examples of just finding the sum of the angles, and then we'll do some where we find some missing angles. So our first, it says find the sum of the interior angles for an octagon. So an octagon, we're given a nice stop sign here. An octagon, if we don't know, has 8 sides. So we're going to try to find the sum of the angles. If there's 8 sides, there's going to be 8 angles for that polygon. So let's use this formula. S is equal to, well, it's 180 times n minus 2. And the S is the sum of the interior angles. The n is how many angles you have. Well, we're working with an octagon, so every octagon is going to have, well, we do 8 minus 2, we should get 6. So every single octagon is going to have 180 times 6, which is 1080. So every octagon, the interior angles are going to add up to be 180. Now these angles, these 8 angles here, they don't have to all be the same measurement. They could have different measurements, but their sum needs to be 1080. All right, our next one. We're going to try to find the sum of the interior angles of a decagon. So a decagon, we have a total of 10 sides or 10 angles, so we're just going to use the formula again. We have 180 times 10 minus 2. So the sum of the angles will be 180 times 8, which is 1440. So every decagon, when you add up the 10 angles inside, should have a sum of 1440. So now let's see how we can use that a little bit to find some missing angles. So let's go on to our next example, the 6th slide here. We have, well, let's look. We have a polygon, and we're given some measurements. X, 75, 105 degrees, and 80 degrees. So if we want to know how many sides it has, we can simply count the number of sides, or we can count the number of angles. They'll be the same for a polygon. And we have 4. So we have a quadrilateral. Now with quadrilaterals, we might know that means the sum is going to be 360. If we didn't know that, then we'd have to go back to the formula, and we would do S equals 180 times, well, there's 4 sides, minus 2. So 180 times 2. So the sum of the angles inside would be 360, which Quadrilaterals, a lot of people tend to just remember. And now, like we did with our triangles, we can figure out this value of x here because we know all 4 of these angles should add up to be 360. So 105 plus 75 plus 80 plus x, you add those 4 together, you should end up with 360. When you add them together, well, 105 plus 75 is 180, plus 80 is 260, plus x is equal to 360, so x should equal 100 then, meaning this angle needs to be 100 degrees in order for all 4 of these angles to add up to 360, which they should in a quadrilateral. So x would be 100 here. All right, let's look at our next example. Different polygon, different angle measurements. Same goal though, we want to find a missing value. So we are given this figure, looks something like this. And our goal is to find the measure of t, which is right here. We're given this is 145, this is 110, this is 95, this is 110, and this is 140. So first, let's figure out what all of these angles have to add up to be. What's the sum of these angles? Well, we have 1, 2, 3, 4, 5, 6 angles. So that means we're working with a hexagon. 6 sides, 6 angles, 6 vertices. So let's use that formula. S equals 180 times, well, we know we have 6 minus 2 here. So S should equal 180 times 4. So S should equal 720. That means these 6 angles should add up to 720. So let's make that equation. Well, we have 110 plus 140 plus 145 plus another 110 plus 95. So we've done all these angles. Don't forget the t, that's the one we're trying to find, plus t equals 720. So let's add some things together. When you combine all of these like terms together, you should end up with, I believe, 600. Plus t is equal to 720. So we get 720 there. And now we're just going to solve for t. And you should get t is equal to 120. And just like that, we're all done. So we have t is equal to 120. That's the measurement for this angle. That will make everything add up to be 720 in our hexagon here. Okay. So on to a couple that get a little more challenging, but the same concept that we're going to apply. So let's try these 2 and then we'll do one last one. So our next one, we'll go with the one to the left on the next slide. We have, and these are very similar to triangles, just we're adding up to a different sum. We have what looks like a quadrilateral here. We're given 3 angle measurements, and we're given that this is 2x down here. And we want to find the measure of all the angles. So we need to find the measure of this angle because we have the other 3. We're working with a quadrilateral, so we should know the sum is going to be equal to 360. And if we forgot, we can always fall back on that equation. S equals 180 times n minus 2, n is the number of sides. So the equation we can make here, well, that is 92 plus 114 plus 60 plus 2x. That should have a sum of 360 because this is a quadrilateral. And then when we combine some like terms down here, 92 plus 114 plus 60, well, that's 266 plus 2x equals 360. So 2x is going to be equal to 94, right? And divide by your 2, so you get 94 divided by 2. We should end up with 47. So the value of x is 47. If we want to find the measurement of 2x, well, you would do 2 times 47. So the measure of this angle would be 94. X is 47. Since this angle is 2x, the angle measurement would be 94 degrees because it's double what x is. And now let's look at our next example next to us. So we have this figure, and we have, let's see, something like this: 71 degrees, 92 degrees, 139 degrees. Then we have 9x and 5x, and we want to find the value of x and the measure of these angles. This is a 71 over here. So first thing we should look at, well, this is a 1, 2, 3, 4 polygon with 5 sides, 5 angles, and polygons with 5 sides, 5 angles, they have a sum of 540. If we forgot that, we would just do s equals 180 times 5 minus 2, s equals 180 times 3, so the sum of the interior angles would be 540. And now we can make an equation from that. 139 plus 71 plus 92 plus 9x plus 5x equals the 540. When you add up all these angles, you should be equal to 540. So let's go ahead and add up what we have over here. 139 plus 71 plus 92. When we add those together, we have 302. 302 plus 14x equals 540. So 14x is equal to 238, which makes x, oops, there we go, x should equal 17. Now if we're trying to find the value of the angles, well, we need to take x is 17, and we're going to need to substitute that back in to the expressions. So 5x would be 17 times 5. So 5x would be, well, that would be 85. So that means this angle has a measurement of 85 degrees. And then 9x, well, you would do 9 times 17. So 9x, and that equals 153. So this angle should equal 153 degrees up here. So we found the value of x and the measure of all the angles. And if you wanted to check and see if these were correct, you can simply just add up all of your angles. 92 plus 85 plus 139 plus 153 plus 71, that should add up to 540, and it does add up to 540, so that means we did it correctly. We found the right value of x. And just like that, we're all done. So on to our last little challenge problem of the day, and then you can try some of these on your own. It is our last slide here, and we are given this figure, and we're given no angles. But we're given that these two angles have a measurement of x, and these two angles have a measurement of 3x. We have 4 angles in total, so we know we're working with a quadrilateral, which means we should have a sum of 360. Again, if you don't know that off the top of your head, go back to your formula. The sum of the interior angles is 180 times the number of sides, or number of angles, minus 2. So you do the number of angles minus 2, multiply that by 180. That'll be your total sum for the angles. So we equal 360. We don't know what any of the angles are, but we do know we have expressions for them. So when you add the expressions together, they should equal 360. And then you can just solve. 3 plus 3 is 6, 7, 8. So 8x equals 360. And then when you go ahead and divide by divide by 8, you should get x is equal to 45. So that means this angle is 45 degrees. This angle is 45 degrees. And when you multiply 45 times 3 to find the other angles, you'll get 135. So these angles up here should each be 135 degrees. And just like that, we're all done. So the key thing from today is really this formula up here in the top right, because this is going to tell you what the sum of the interior angles are, and then it's just like what we did with triangles. You're adding up all the angles to equal whatever that sum is. So in this case, the sum was 360. That's because it's a quadrilateral. A pentagon was 540, and so on. So this formula really helps you make the equations because it's going to tell you what the sum should be, and then you're just adding everything up. Alright guys, have a nice day.